Hi everyone, my name is Mr.馳. I'm a master in CBME program at HKUST. Today I'm going to do a presentation as part of requirement for my course CBME 5110. Okay, let's start. This is my poster. My topic is supported gold catalyst for isobutene oxidation to MMA synthesis. As we know, methacrylate, we usually call it MMA, is a type of important chemical raw materials. It can be synthesized by several routes such as C2, C3, and C4. C4 routes use isobutene to synthesize MMA by oxidative esterification reaction. We can call it OE reaction. Compared with other traditional routes, this route has short precise flow, simple operation, and light byproducts. The step 2 of OE reaction needs noble metal catalyst. Gold catalyst has great application potential in OE reaction. Supported gold catalysts with 1 to 5 nanometer size show high selectivity in the reaction, which is different from other noble metals such as palladium or ruthenium. So if we manage gold catalyst better in OE reaction, it will greatly improve MMA production. And this poster aims to study the potential factors that may affect the catalytic performance in isobutene OE reaction. First, let's take a look at the methodology. We need to use this picture again. This is isobutene OE reaction. We oxidize isobutene into methacrylate. We can call it MAL. And then esterify MAL into MMA. The step 2 will use gold catalyst, so we will focus on the step 2. I choose 3 factors to study the performance of supported gold catalyst. There are different support components, different support shapes, and different gold particle size. We need to measure the conversion of ML and selectivity of MMA, and also need catalyst stability test. Then, after collecting data, we need to analyze it and discuss these results and finally come to a conclusion. This is methodology. Then let's turn to the experimental results. In 2013, Suzuki synthesized gold nickel oxide catalysts supported by silicon dioxide, aluminum oxide, and magnesium oxide with core shell structure. They used it for the first time in the reaction of MAL esterification to MMA. Its catalytic activity is nearly 10 times higher than that of traditional palladium and light catalyst, and can maintain the stability of structure after 1,000 hours of continuous testing. Han synthesized a kind of gold nickel bimetallic catalyst modified with lanthanum and magnesium elements, and supported with super large mesopolar silica. Compared with single gold or single nickel, this new catalysis system with lanthanum and magnesium has better activity and selectivity. However, the activity and selectivity of the system with single lanthanum or single magnesium is relatively low. We can also see the single nickel has rarely conversion and selectivity, but when it is added into gold catalyst, it can enhance the gold catalyst performance a lot. Trimpalis reported a kind of nickel-gold single atom alloys catalyst. They found that the addition of a small amount of nickel could significantly increase the activity of the catalyst, while pure nickel catalyst had little activity in the reaction. One's team studied the catalytic properties of gold nanoparticles with different supports in the OE reaction of MAl to MMA. By comparison, it was found that there was a strong correlation between the base side of the support and the reaction activity. The gold nanoparticles supported by magnesium oxide and hydroxide, which have more strong base size, showed the best activity in the reaction. Besides, the size of the gold particles also affects the reactivity. The smaller gold particle has higher conversion and selectivity. Gao studied the effect of 3 different morphologies of hydroxyapatite supported gold nanoparticles on the catalytic OE reaction of MAl to MMA. The results show that the needle-shaped HAP has better reactivity and selectivity than the lamella and rod-shaped HAP. Okay, now we turn to discussion. We can see from these results, nickel oxides, magnesium oxide, and hydroxide can significantly improve the conversion of HAl and the selectivity of MMA. It may be because these particles can form alkaline species and provide more strong base size, which can absorb methanol. Besides, smaller size can also improve the catalyst performance. The small size means high specific surface area, which can enhance the absorption process. Another factor is specific support shape. Like needle-shaped support. It can form strong interaction between gold and supports and make gold easy to be wrapped by support. That means it is easier to achieve high dispersion and high surface area, which can enhance catalyst reactivity. However, there are some contradictions in this paper. Suzuki's focus more on nickel and didn't explain the role of gold in OE reaction too much. In Han's paper, they added magnesium hydroxide into the system, which greatly limited the application of the catalyst in industry. So their catalyst has no practical meaning. For the Tripalis experiment, the content of nickel was too low, only 0.005% by weight, which cannot support their conclusion. I think they need to do more experiment with a series of nickel content. one tested different supports but didn't control the gold size in these supports. Different supports, their different supports have different size. It might affect the results. In Gauss paper, I didn't find any obvious contradictions. So maybe it's a good paper. Okay. Finally, let me make a concluding remark. I think in the future, the above factors can make great contributions to the development of high-efficient and stable supported gold catalyst. And these kind of catalysts can also used for other ester production, such as methyl acrylate and isoacrylate. However, gold catalysts still need to overcome the cost problem and equip issues, which will provide the possibility for the future industrial application of gold catalyst. Okay, that's all. Let's see my poster again. Okay, thank you so much. Bye bye.